Hello viewers, yes, let us continue with now. Today let us talk about the passage time, about stochastic process again. Remember, I'm Shaka Annual, the math tutor, and remember, I'm just taking you through mathematical scenes, and I think we are enjoying the YouTube channel. But remember, don't forget to like, subscribe, and share, comment for more videos like this one. And today we'll just talk about the fast passage time. Oh, here we shall be interested in the understanding or finding out the number of time steps to reach state J from state I. Like how long does it take me to reach state A when I'm from state I? And this time round, we shall call it the passage time. And then we shall relate that our MIA equal to the number of time steps taken for me to reach state A from state I. Now to get the formula to be used, we shall take a sample, like an example. Like take an example that I'm in state I, but me being state I have to first leave state I to state 1, or to state 2, or to state, call it state M, because we have M states. But now, after leaving these state I will have to reach state A. Now, I want to know how many time steps will I take to reach state M from state I. Now remember, me leaving state I for state 1, so it will be the probability of I 1. This also will be probability of P I 2. Then you have probability of P I M. Now remember, we're talking about the number of time steps I will take to reach matrix A, to reach state A. Now this is going to be the same as having. Remember, I've made one step from coming from I to state 1. Then here I'll be having one time step, first one step plus now the steps I'm going to make from state 1 to state A. Also here I've made one step first, therefore it will be the first step I've made from I to 2 plus M to A. Then also here we have the one step I've made from I to M, so it will be 1 plus now M. So in the meantime, the time M, capital M, which is our number of time steps, M is going to be now from M to A. Likewise, if we call this M, we call it K. Like we have K states, then it's going to be M, K, A. And likewise, I will say that my M from this diagram, I've shown that. Remember, I have first leave I to give any state. I leave I to state A, state 1, to state 2, to state M. Then the time steps it will take me. So it will be the probability of me leaving state I plus times the number of time steps I'm going to make from that state I, from that state 1 I have gone to. I'm saying that this is the same thing as having that my MIA, the same thing as having summation, the probability of me leaving state I for K, for the K state, times 1 plus the steps I'm going to make from that K that I've gone to state A. This is going to be the formula I want to use, where K is contained in our S space, and then we said that our S is containing 1, 2, up to M states. I think, members, this thing will make more sense if we try to apply an example. Now, let me give you an example and we see how we can maneuver throughout this. Now, the first, we shall use the example I used in the previous video of also a transition diagram. Now, if I give an example of transition diagram, is that we shall always in perspective of this to make our work interesting. I'm saying that this is the formula we're going to use. Now, take an example. We have a transition diagram. Like we have 1 here, 2, 3, then 4. We say the probability of me leaving 1 to 1 is going to be, I want to leave 1 for 1 is going to be is going to be 1, yes. Then the probability of me leaving 1 for 2 is going to be 0.5. Then the probability of me leaving 2 for 3 is going to be 0.5. Probability of me leaving 3 for 2 is going to be 0.5 again. Probability of me leaving 3 for 4 is going to be 0.5. Then the probability of me staying at 4 is 1. Yes. Now also here shall need to know that yes, shall need to know that what will be the number of time steps I will take for me to leave 1 for 4. I'm at 1. We said our 1 is an operation state. Therefore, if I'm at 1, I'm unable to go to 4. Therefore, me leaving 1 for 4. Yes, it's going to be 0 because I'm unable to leave 1 for 4. Therefore, my number of time steps I will make for me to leave 1 for 4 is going to be 0. Likewise, what will be the number of time steps I will make for leaving 4 for 4? Like I'm at 4, then I want to go to 4. Therefore, the number of time steps I will make is also going to be 0. Therefore, should be just knowing this, the meaning of M14 equal to 0, and then M44 equal to 0. Should be knowing the meaning. Now, if I'm asked how many time steps will I make to reach state 4, like question may be like, how long will it take me to reach state 4? How long will it take to reach state 4? Therefore, I need to first get to know these conditions of mine. Like, if I'm in state I, and state I is my abbreviation state, I'm unable to leave state I. So it's state 1. Therefore, me leaving state 1 for 4 is going to be 0. I'm going to take 0 time steps to reach state 4 because I'm unable to reach 4. Then, if I'm at 4, the number of time steps I'm going to use to reach state 4. When I'm at 4 again, I will just use 0 time steps. Now, my task is finding now if I'm at 2, what's going to be number of time steps from 2 to 4. Now, from our equation, you see that you shall see the probability of me leaving 2 for a given state, like me leaving 2 to 1 is going to be probability of me leaving 2 to 1 is going to be 0.5. Now, into one step I've made from leaving 2 to 1, then plus the steps I'm going to make from leaving 1 to 4. Am I making sense for what I'm saying? I'm saying that from the probability you are from defining here, the question that has been here down, I will say that I will leave 2 for 1, which with a probability of 0.5. This is 0.5. But now I've already made one step, which is this one step I've made from coming from 2 to 1, but also plus the number of time steps I'm going to take from 1 to 4. Yes. Now from there, I say now plus, I'm also now leaving 2 for 3, with a probability of 0.5, into now 1 plus the probability of me coming from 3 to 4. That's the number of time steps from 3 to 4. Because I've already made one step from coming from 2 to 3. Then likewise, the same thing as having, yes, I'm coming from 2 to 4. Therefore, I'm unable now to go to 4 because there's no arrow taking me to 4. And then this is going to be my question 1. Like, I'm going to have my M2 4 is going to be the same thing as having 0.5, yes, plus 0.5 M14 plus 0.5 plus 0.5 M34. Then my M2 is going to be the same thing as having, remember, M14 is going to be 0. I have now 0.5 and 0.5, I have 1 plus 0.5 M34. Then this is going to be the same my equation 1. I think I'm making sense there. Now, if now I want to, at the meantime, I'm going to take, I'll take the number of times I'm going to take from state now 3 to state 4. My M3 to 4, the same thing as having. Then I want to see the probability of me leaving 3 to 2, which is going to be 0.5 into 1 plus the number of times I'm going to make from 2 to 4. Now plus also the probability of me leaving 3 to 4, which is going to be 0.5 into 1. I have moved already 1 time step plus now how many time steps I'm going to move from 4 to 4. Now this is the same thing as having my M3 4, same thing as having 0.5 plus 0.5 M24. Yes. Now plus plus what? 0.5. Yes. Now into, yes, into what? Into 1. So 0.5 then times plus 0.5 M44. But now recall that M44 is 0. Therefore, I'll be left with M34 equals to 0.5 plus 0.5, which is 1, plus now 0.5 M24. And then these are going to be our 2 equations to solve. Equation 1 and equation 2. Now, if I try to solve equation 1 and equation 2 simultaneously, I'll just bring my M4. I'm saying that my M2 is the whole of this. Then if I put it substitution into this equation here, what's going to be my M4 and my M2? I think I have to get my M24, then my 3, 4. Me pressing my calculator, I'll have my answers as if I press the calculator, I have my M M34 as 2 and M24 as 2. Like, try to see if I get these answers 2 and 2 here. Like, the number of time steps I will take to me leaving from 3 to 4 will be a 2 and then a 2. By just solving these two questions simultaneously, I get M2 and M4. And therefore, I'll be sure that I'll take 2 time steps from 2 to 4, like me coming from 2 going to 4. I'll take 2 time steps, like I move twice. And then me coming from 3 to 4, I'll also take 2 time steps using this equation. Now, members, I want to also take, I think this is simpler, and this is the example I can give. You can also try now using that second example I gave in the previous video to see how can we get those time steps. Now, I want just to make just one clarification that in the notes, if you try to reading from other sources, you will find that they will call the probability, they will call the hitting probability. Hitting probability. First, we say that hitting probability, we call it HIA. Some books will just call it HI, like the probability of leaving state I for a given state A. And then you find probability for them calling it AI, like the probability of AI meaning the probability of reaching a given state A from I. Okay, they will not always give you the A, like telling you that I'm with this given state. Also, the first time passage, like the time taken to reach state A, to reach given state A, to reach state A. First, we've called it the MIA, but some books will call it now, you may find DIA or DI. This DI meaning the time taken for me to leave a given state from state I, like reaching a given state I from state I. Members, I think for now, this is very interesting, and I think it has been a wonderful video. Although it is short, but I think you will enjoy it. And members, I want to just tell you something today, that this coming week we are voting for Nyanz Trevor. Nyanz Trevor is our chairperson, Musa. Members, don't forget to vote for Nyanz Trevor, because he's a man, he's helping the channel, he has provided everything for the channel, he's buying markers, he's giving us time. Okay, just please vote for Nyanz Trevor for the chairperson, Musa. Come next week, Wednesday, and we shall be fine to go. Thank you for watching. I'm Shaka Anwar, the mass tutor, and Nyanz Trevor is our chairperson.